8th grade from Jawaharlal Vidyalaya from India. I'm honored to present my project titled Areca to Eureka, Utilization of Areca Husk for Sustainable Packaging and Construction in a Circular Bioeconomy. This work was carried out under the guidance of my co-authors and mentors, Dr. Anil Kumar Sethi, Dr. Vipin Kumar Chawla, Dr. H.R. Prabhuda, and Dr. K.V. Viru. So we are arrived at the question, what is Areca? Areca palm tree is a tropical tree usually grown in India for its nut known as the betel nut. The outer covering of the betel nut is known as the Areca husk. India is the largest producer of Areca husk with over 65% of global Areca nut production. It also has over 9.4 lakh hectares under Areca nut cultivation. Every year, over 6 million tons of Areca husk is produced, which is projected to reach 30 million tons in the next decade. But what is more important is that most of this Areca nut is grown in the southern part of the region known as the Western Ghats. It is ecologically sensitive and it is threatened by industrialization. It is also UNESCO World Heritage Site. And Areca nut farming is the livelihood of thousands of small farmers. And what they do is the Areca husk is considered as a waste and it is being burnt, which emits harmful gases and also causes environmental pollution. So our idea was to utilize this biomass, which is which has a considerable amount of cellulose and lignin, to make sustainable packaging and also construction material. So our objectives are to add value to Areca husk for its utilization in local construction and also packaging application. So primarily we did two specimens. One is a composite particle board which is done with waste plastic and Areca husk, and the other one is Areca flexible board which is done with polyvinyl alcohol, PVA, and Areca husk. So this is a composite board. The primary uses of this are as flooring material and also roofing material. So the short-term objectives are just to study the feasibility of manufacturing formaldehyde-free particle board and also to reach the parameters set by the Indian standards for particle boards. And the long-term objective is to reduce the dependency on aminoplastic resin and also to use recycled waste plastic and also to add value to other Areca husk. So the key objective is to develop formaldehyde-free particle boards using Areca husk and recycled plastic, and to meet IS 3087, the Indian standards for particle boards, and to promote sustainable alternatives in panel manufacturing. So this was the methodology which we followed. So the ingredients were shredded Areca fiber, which is 60%. We had actually done two ratios. One is 60% Areca husk and 40% of plastic, recycled plastic. And then the other was 50% of Areca husk and 50% of the plastic. So the shredded Areca nut fiber and also shredded milk powders. Milk powders is the plastic. And then coupling agent was maleic anhydride graphite polypropylene was used, which was about 3% of it was used. So the process was Areca fiber and plastics were mixed thoroughly using a high-speed mixer, and the mixture was spread into a mold of 1 feet by 1 feet, and it was pre-pressed. And the pre-pressed mat was again pressed under a hot press with 145 degrees Celsius and specific pressure of 20 kg per centimeter square for 30 minutes. And then the press mat was removed from the hot plate and was allowed to cool down, and it was conditioned for 1 week before doing the testing. And this is the flow chart of the same. This is the residual Areca husk particles, and which is mixed with the shredded milk plastic, and then it is pressed in the hydraulic press, and this is the board which we achieved. So we tested that for density, moisture content, modulus of elasticity, water absorption, thickness, swelling, and internal bonding test. It was done in accordance with IS 3087 for flat press single layered boards. And this is the test results which we achieved. So here you can see P1 and P2. P1 has 60% of Areca Husk particle and 40% of shredded milk plastic. And P2 has 50% of Areca Husk particle and 50% of plastic. And you can see the IS requirement for the density. It's around 500 to 900. And you can see that both the boards achieved that. The moisture content was about 5 to 15, which was again achieved by the boards. The thickness swelling was also achieved. The modulus of elasticity, however, it was not achieved. And the internal bonding strength was also achieved. You may wonder that since P2 has relatively more plastic than P1, then the water absorption, thickness, swelling, and also moisture content of it should be better than P1. But since we faced some problems in the pressing, in the hot pressing and also trimming, the results varied. And next one which we did was Areca flexible board, and the methodology was quite similar. Here shredded Areca fiber was used and also PVA was used. The Areca fiber were first oven dried for 2 hours, and then they were coated with the PVA solution, and then it was again pressed in a hot press for 80 degrees Celsius with 15 kilogram per centimeter square for 15 minutes, and again it was conditioned for 1 week at room temperature. And this is the flow chart of it. That is the first photo which you can see is raw Areca husk, and the second one is the cleaned Areca husk. And then it was manually mixtured and it was pressed. Again, they were evaluated for modulus of elasticity, modulus of rupture, thickness swelling, and internal bonding. And these were the results. And one main thing in this is that modulus of elasticity, it is quite less, which it shows that the board is very flexible. And since we are using it for packaging applications, that is very much needed. And these are the applications for that. For the flexible board, it can be used as nursery bags for the Areca plants or for any plants in that matter. And seedling trays and also secondary packaging materials such as carton boxes. And for the composite particle board, it can be used as false ceiling panels and also roofing panels. So the impact and significance of this is that it reduces air pollution which is caused by burning of Areca husk. It also promotes bio-based low carbon materials, and it also promotes recycling plastic. It adds value to farm waste and plastic waste, and it also boosts rural income and jobs. And it aligns with sustainable and SDG targets. It addresses SDG 8, 12 and 13 with a decent work and economic growth, responsible consumption and production, climate action. So in conclusion, although the mechanical properties of the composite board were lower than those of industrial material, but the thickness swelling of it is quite promising. And then the method used to make the plastic bonded boards involving manual mixing and hot pressing, it presents limitations as the uniform distribution of the binder, which is the plastic, it could not be achieved. Despite its limitation, the physical mixing and pressing was chosen because of its availability in the study region. A more effective alternative could have been using the twin screw extrusion method, which would have made the plastic more distributed, or which would have resulted in better mechanical properties. And the relatively low modulus, as I said earlier, modulus of elasticity in the PVA bonded board suggests greater flexibility, making it a good material for nursery bags and also carton boxes. I would like to thank Dr. Prabhuda, Dr. Vipin Chawla, Dr. Anil Kumar Sethi, Dr. K.V. Vedamurthy, Dr. Manoj Kumar Patil and Ms. Neelam Negi for helping me and supporting me throughout the project. Thank you. I would also like to thank the ACC for giving me this opportunity to present my project. Thank you.
Okay, thank you very much. Very, very good. Excellent presentation. You are in the 8th grade.
Yes.
and you're probably the youngest speaker in the whole conference. That makes me feel so proud of you. And I really enjoyed the way you presented it like an undergrad student. And the terms that you use, modulus of elasticity and things like that, I'm awestruck. And you're a prodigy and you're a future of science. Very best for your future. All the best.
Thank you very much.